Hey everybody, welcome back to this course. In this video I just want to go over how to use the oscilloscope. So right now I've got this RC filter, right? So I've got power supply coming into the resistor, and then I've got our ground of the power supply tied back to this capacitor, and these guys are in series. And here on channel 1, right, this blue wire, I will be probing the input across that resistor and ground, and then on channel 2 I'm probing the output, which is this junction between the capacitor and the resistor. So I'm going to go ahead and take a look at the oscilloscope here at the bench. So here's our oscilloscope, right? We've got the vertical knobs for both of the channel, and that allows us to change, right? If I turn this guy, it adjusts the vertical scale. And the same thing happens for this second channel knob. If I turn these guys, it will adjust the vertical scale there. And then I've got the horizontal knob here. It adjusts this horizontal scale rather. So if I adjust this, you can see that that time scale is changing. I've also got a bunch more buttons here. So here's the trigger. If I click on the trigger, it brings us to this trigger menu, and what we usually want to do is set it to be a rising edge. And so right here it tells you the slope, so it's triggering once channel 1 is going up, right? So our source is 1, we're triggering on an edge, and we're triggering on this rising edge slope. So when the voltage shoots up past whatever value is here on the side, that is when we'll start collecting data. And we can adjust the trigger level with this knob, so it goes up and down, and you can see the value up at the top right of the trigger. So that's for the trigger. Right now I've got it set to single. We could also have it running continuously if we hit run, right? So right now it's in the stop mode, stop state, so we gotta hit run again, and now it's just collecting data. And it'll populate, yeah, so once it gets enough data it'll start populating, but I'm going to go ahead and hit single. And what I'm going to do now is I'll turn on the power supply, and you'll get to watch the data come up. Right, so it just triggered, and now, right, we see that the voltage across the capacitor in green and the voltage of the input source in yellow, right? So there's our two waveforms. What we also want to do is, hang on a second. So another thing that we might want to do is measure. And what you want to do is click on cursor. And so there's this cursor soft key, we click on that. And usually what's helpful is if you set the mode, right? So we click on mode, and then we use this utility key knob here to set the mode. So we click mode, change this, and usually what's helpful is to set it to tracking the waveform as opposed to manual. So if you set it on manual, you can move the cursors wherever you want, but if you track the waveform, then they'll be following the waveform that you're set at. So right now we're set to source 2 on X1, and we're set to channel 2 on X2, right? So we've got these two X cursors, and I'll go ahead, we can move them with this measure knob here. Right, so right now I'm moving X2, and I've already went and set X1 to the 0 position, right? So right now X1 is at 0 seconds. So I'm going to keep it there, and I'm going to set, I'm going to select X2. You know, I just moved X1 over 10 milliseconds, so I'll move that back here. So we set it to 0, and then we want to set X2, select X2, and now we move the measure knob here, right? So we're moving X2, and we're tracing this waveform, and it shows you the Y values and the change in X, right? So maybe we calculated some tau, and we want to set it to 1 tau at maybe 100 milliseconds, and so on and so forth. Right, so this gives you a way of verifying physically any simulations that you would make in LT-SPICE, or even to just try to see what's going on in time. right? So in this case, our capacitor is charging up once we turned on that power supply. So another thing that you should probably check for is you want to have these channels set with DC coupling. Right, so if you just click on the channel, so I just clicked on channel 1 here, and you can select the coupling and use this utility knob to set the coupling. And we're going to be using DC coupling just because, you know, in this case our power supply is outputting a constant 1 volt. If it was a sinusoidal voltage, you know, centered about 0 volts, then, and if it were AC coupled, then we wouldn't see anything, but we won't get into AC coupling for some time now. Another thing that you want to make sure is that your attenuation ratio is set correctly, right? So we've got these channels, and you can see that channel 1 in yellow is 1:1. And if we look back at our probes, so if you're using the BNC to, well, any of the BNC cables on the rack back there, they're going to be 1:1. But these probes have a little setting switch, and I've got these both set to 1x. So I'm going to be using this 1:1 ratio. But how you would change that is, right, you select the channel that we're interested in. So right now we're already set on channel 1. And I'm going to click on probe, and I'm going to click on this ratio, and it says decibels, but we can just adjust it here. Right, so now it's 0.5 to 1. Yeah, right, so we want it to be 1:1 in this case. So that's how you would go about fixing the ratio, right? If you're seeing some unexpected voltage, right? So you'll probably know that your attenuation ratio is off there. So I think that's all I wanted to talk about here. I'll catch you guys on the next video. Thanks for tuning in.